Bismillahirrahmanirrahim. Welcome to MIT. Today our topic is permutation and combination. The paper we are going to solve today is paper 060613, session May June 2024. And before moving on to our question, I would like to inform you just two notation. One is for permutation, the other one is for combination. The permutation notation is this one. Means permutation is written as NPR, whereas combination is written as NCR, which is sometimes told as N choose R. Okay, so NPR, P for permutation, P for permutation, and C for combination. Well, so whenever we solve the problem of permutation, then we will apply NPR, and if we understand that it's a combination solution, then we will apply NCR. Then we will know what does NPR mean. Actually, in case of NPR, n will be n factorial. This symbol is called n factorial. Okay, this is factorial symbol. So, and this is initially I am just explaining in brief. Later on, when we go through the solution, we will understand and explain it better. Well, so NPR numerator will be n factorial always in both cases. In the case of permutation and combination, both cases numerator is n factorial. In case of permutation, the denominator will be n minus r, n minus r. So permutation is very simpler, that n factorial over n minus r, whereas in case of combination, numerator n factorial is unchanged, but in case of combination, n minus r extra r factorial should be written. So in combination, something is repeated from permutation, it's as same as permutation, but extra is r factorial. This r factorial will go with n minus r factorial. Well, this is the notation, and we will come to know in details later on. First of all, we will have to identify whether the given problem or question is on permutation or combination. Simply, there are two clue words which can make sure that this is either permutation or combination. Look, in all permutation problems or question, you will find arrangements. If arrangement matters, if we are supposed to do arrangements, then permutation. So the clue word is arrangements. For arrangements, always we will apply permutation method, and for selection or choice, if the question contains any one of these two, one is selection or choice. If it is about to be chosen or selected, then combination. So simply from the question we will pick up two words. Either it will be arrangements. For arrangements we will apply permutation, and for selection or choice we will apply combination. Let's start the first solution. The first question belongs to paper 060613, May June 24. That means this is a question of admits, May June 24, and paper is 13 paper, that means paper 3, uh, paper 13 0606, session May June 24. The first question says, it is question number 7a, says a 6-digit number is to be formed using the digits 0 until 9. So there are total 10 digits. From 0 to 10 there are total 10 digits. Then the 6-digit numbers cannot start with 0. Each digit can be used at most once. That means we cannot repeat any digit at any in any 6-digit number. Find how many 6 digits numbers can be divisible by 5. So there are two parts. First of all, we will have to find how many numbers can be formed, then how many numbers among them are divisible by 5. Well, there are total 10 digits. Out of 10 digits, we will arrange, first we will pick up 6 digits, then they will be arranged. Remember, just few seconds back, I told that whenever arrangement matters, then we will have to apply permutation. As you are forming different numbers, so arrangement is the fact here. You cannot write the same digit twice. That means it's all about arrangement. Now let's see, for arrangement there are total 10 digits. So we do have 10 digits. Out of 10, we will have to form 6 digits number. That means from 10 we will choose 6. Let's see, the second condition is the number must be divisible by 5, and we know a number, all the numbers which contains either 5 or 0 in the ones place. Look, there are many numbers, uh, there may be many digits which may have many digits, but the units place or ones place must be either 5 or 0. So there are two cases: a number or any number which contains 5 or 0 in ones place is divisible by 5. Now as there are two conditions, okay, we will solve it stepwise, one by one. Suppose in ones place we are having 5, okay, in ones place we are having 5, then the first place should also be dissolved. In the first, if 5 is fixed over here, look, 5 has been fixed, and total we should have 6 digits: 1 2 3 4 5 6. There can be total 6 digits. Out of 6, 5 has already been fixed in one's place. Then we are, there is another conflicting case, that the first digit, look, the here there is a restriction, or we know that 0 cannot be at the beginning of the number. So if 0 cannot be fixed, 5 has already been fixed, how many are remaining there? Total 9 digits. There were 10 digits, but 5 has already been arranged. We cannot make any change to the position of 5. So there remains only 9. Out of 9, we cannot use 0 at the first place. 0 cannot be used at the first place. So how many digits are left? There are 8 digits. Out of 8, in the first place, out of 8 we can choose only one. For the first position, we, out of 8 digits, we are choosing one. How to, not choosing its arrangement, so how to use this, for how can we make these arrangements? As there are 8 digits left, 2 has gone, 0 and 5 have gone away, then there are remaining 8 digits. Out of 8 we will choose one. So how to write this? We will arrange one. How will we write this? This will be written 8p1. Already I have told that as arrangement matters, it's permutation question. So 8p1 means out of 8 digits we are choosing one. So two places have gone away, first place as well as last place. There remains now 4 places left. 4 digits. We can now arrange 4 digits. So let's see how many digits are left. 5 has gone away for the last place, I mean one's place, and for the first place one digit has gone away. So how many digits are how many digits can we take more? We require 4 more digits. 4 more digits, out of which one has been taken away for the last place, one has been chosen for the first place. So remaining there are 8 digits are left. 1 plus 1 2 went away, 8 are left. Out of 8 we cannot choose all of the 8, we will arrange only 4. That's why here we have written 8p4. So ultimately how did we do? We have, first we have placed the ones digit which has been already fixed, it should be 5. Then the first digit cannot be, 0 cannot be at the first place. That's why from out of remaining 8 digits we have chosen one for the first place. So first as well as last place have been fixed. Now there remains 4 more places in between them, and for this 4 digit total we have 8 digits. Out of 8 we have arranged 4. That's how we have written 8p4. I have written this in words. I can show you. Here it's written when 5 is in one's place. Look at this. When 5 is in one's place, number of arrangements. Okay, number of arrangements already I have shown that first for the first place out of 8 we are choosing 1 into for the next 4 positions we have chosen 4 from 8. Now the question is third, one's place is it's 5 already fixed, so you cannot make any change. As this is already fixed, we don't need to arrange this. So we will arrange for the first place, we will arrange one digit out of 8, and if 5 has gone away, first place has gone away, then there are remaining 8 digits. Out of 8 we are choosing 4, we are arranging 4. So let's see. At the very beginning I have told 8p1 means first 8 factorial. This one, upper one, will be numerator, then the denominator will be subtracted. Okay, that means 8p1 means 1 will be subtracted from 8. 1 will be subtracted from 8. If we subtract, it is going to be 7 factorial. Same goes for the second case. 8 will be the numerator, 8 factorial, and we will subtract 4 from 8, then we will get 4 factorial. So 8 factorial over 7, 7 factorial into 8 factorial over 4. If we use our calculator, this one is actually, it will be 8. Okay, but we don't need to extend this. Actually, using your calculator you can find 8 factorial over 7 factorial into 8 factorial over 4 factorial. Using your calculator you will find 13,440. Now this was the only one case, that when in the ones place there was 5. Look, in the ones place there was 5. Just we have solved this. Now the second case, we have already explained that there may be 0 also in one's place. If 0 is in the one place, then what will happen? Suppose this is 0. Okay, then for the first place, now how many digits are left? 0 has already gone here, so there are 9 digits, and we can fill 5 places. 1, 2, 3, 4, 5, total 6. So 0 has been fixed or placed. There remains 9 more digits. Out of this 9, anyone can be arranged. They can interchange their position. So out of 9, now we are choosing 5. There is no more restriction. 0 has been fixed. 9 are remaining. Out of 9, we will arrange 5. All these 5 places can be filled up by any one of these 9 digits. So what will be our solution? Our solution will be, when 0 is in one's place, number of arrangements is equal to only 0. Look at this, 0 has already been fixed, so we don't need to think over this. It's this place has gone away, we can arrange this. How can we arrange? Out of 9 we will arrange 5 digits, and that is simply, we can write 9p 9p5. So we, as 0 has gone away, we don't need to calculate 0. Except 0, there are 9 digits. Out of 9 digits we will fill up 5 places or 5 arrangements. So it can be written 9 factor 9 is on top, and if we subtract 5 from 9, it is 4 factorial. So 9 factorial over 4 factorial is equal to 15120, means 15,120. So initially, in first case we have got 13,440, and in the second case we have got 15,120 arrangements. So if we add up total arrangements, we will write number of total arrangements is equal to first quantity plus second quantity is equal to 28,560. I think you have understood at least to some extent. If we try to be attentive in the next solution, you will be better in understanding the fact. But in brief, we have learned that for arrangements, we apply permutation method, and for choice or selection we apply combination method. Here all the questions, whole topic is based on actually arrangements, because number, if you want to form numbers with different numbers of digits, then it is actually arrangements, because one digit cannot be written twice. Let's start solving the next one. The next question belongs to 0606 paper 21 May June 24. 0606 21 paper 21 May June 24. Let's see what the question is. The question is, there are 3 women, 2 men, and 4 children in a choir. The choir stands in a single straight line. Find the number of possible arrangements. Look, this is the clue word, arrangements. If the first person and the last person are both women. Well, as the clue words is arrangements, that means we will have to apply permutation concept, arrangements. Okay. So for permutation concept, first of all, see how many people are there. Total 3, 2, 5, 5, 4, 9. Total 9 people. Out of 9, they have already fixed first place and the last place. These two positions have already been rearranged or arranged. We cannot do anything to this. So let's see the remaining one. Remaining, how many people are there? 7. Out of 7, there were total 3 women. Okay, out of 3, 2 have been already arranged, and then we will choose remaining 7. The remaining 7 will be rearranged. So remaining 7, if we want to rearrange or arrange 7 people, we will simply write 7p7. We have written here 7. I have written some words in favor of this. First of all, we choose 2 women out of 3. This is a point. Look at this. They have told that 2 women, but as there are 3 women, out of 3 we have chosen 2. So this is the one step, means choice is included, means selection. That is, actually the question includes both the combination as well as permutation, because if as there are 3 women, we are not choosing all 3, we are choosing 2. We will have to select any 2. So for selection, first of all we will have to apply combination method. Then for the next 7, for the next 7 people, it will be permutation. And it has been written over here. Then remaining 7 people will be arranged as 7p7. Then chosen 2 women can interchange their position again. That means as we have chosen the first women and the second women, they can also be rearranged. The first one can go, last one can go to the first one, and the first one can also come to the last one. Let's see the solution, how to write. First of all, we have chosen, here I have written number of total arrangements. First, what did we do? First 2 men and last 2 men. Out of 3, we have chosen 2. So we have written that combination. We have chosen or selected 2. 3, choose 2. After that, for the remaining 7 places, there are 7 people and all of them will be rearranged. So we have written 7p7. Then what about the first and last 2 men? Look, as I have already told, the first one can be arranged or can change its position to the first place, last one, and first one can come to the last place. So there is also arrangement in 2 factorial ways they can be arranged. So for the first one is combination, and for combination we have already come to know that 3 numerator is 3. This 3 will be the numerator, and these 2 first, these 2 should be written here, and then 3 minus 2, remember it is to be separate. In combination, the total number, the chosen number should be subtracted from total number. Here total number is 3, total number is 3, and if we subtract this chosen number 2, it will be 1. Okay, then again this 2 chosen number is always commonly written in the denominator. So what should it be? 3c2 means 3 factorial over 2 factorial first, then subtraction means 1 factorial. And now this one is permutation. For permutation, what do we do? The numerator is written first. If numerator is written, denominator is actually what? The subtraction. If we subtract 7 from 7, what will it be? 0. That's why 7 factorial over 0 factorial. That means 7p7 means 7 factorial over 0 factorial. Same goes for the next one, 2 factorial, the numerator, and the denominator is subtraction. If we subtract, it is going to be 0 factorial. Using our calculator, if we write 3 factorial into 3 factorial into 7 factorial into 2 factorial, and if it is divided by 2 factorial, remember, in common algebra, we know that 0, if 0 multiplies something, it's equal to 0. But in case of permutation combination, 0 factorial is not 0. 0 factorial means 1. So don't get confused that how can it be defined if the denominator is 0. It's not 0 actually. 0 factorial means 1, means one way 0 can be, any number can be rearranged. So 0 factorial means 1. So your denominator is going to be 2. 1 factorial is also 1. 1 factorial as well as 0 factorial are 1. So 2 factorial, 0 factorial, 1 factorial, all of them together will be 2. First you will multiply the, this is the numerator, 3 factorial, 7 factorial and 2 factorial, then it will be divided by 2. Ultimately you will get 30240 as the answer. That is what the number of arrangements they have told us to find. What does next question say? The next question says find the number of possible arrangement. This is also arrangements. Okay, that means permutation concept should be applied. If all the children stand next to each other, that means there were 4 children. Let me show you how many children were there. It is written that there are 4 children. Well, so if the 4 children stand beside each other, the first one, second one and third one I have shown here, these are for the children. 4 children have been arranged as a group, that means they stand with each other, means whole of this is actually one body now. As they are standing with each other, they cannot detach each other, so it is one group now, whole of them is one. After, then except these children, how many are left? There are total 5 are left, because total there were 9. Then if this total one, all the children are considering to be 1, if 1 and next 5, total 6, so 6 factorial ways they can be rearranged. Then again, if we talk about these children, look at this children, there are 4 different children, they are not identical. As there are 4 different children, they can also interchange their positions, they can also be arranged. So we will have to apply 4 factorial 4p 4. It means these children, first what will we do, we will suppose all the children as they stand together, so the all of them are one group or one unit. Then remaining there are total 5, so total one group plus 5, one unit plus 5 units, total 6 units, so 6p6. Well, after that the children, they can also interchange their positions in 4p4. I have written here, let me see the writing. The writing is considering, considering all children as one body, because they are together, we have total 6 units. Okay, 5 remaining people and 1 all the children, 6 units, which can be written as which can be rearranged as 6p6 here. 6p6 total, all of the children together 1 unit and rest 5 units, total 6 units, 6p6. Well, then these 6 unit, these 4 children, again the 4 children can interchange their position among themselves. Okay, so they can be chosen, they can be also written as 4p 4 ways. 4 children out of 4, all of them will be rearranged, so it will be 4p 4 ways. So number of total arrangements I have written here. Look at this number of total arrangements. First there were 6, overall 6 units, so 6 factorial ways or 6p6, 6 factorial, and look 6p6 and 6 factorial are actually same. because if you subtract 6 minus 6, it's 0. 0 factorial means 1. So if something is divided by 1, it is actually all the same. So 6p6, total 6 units, that's why we have written, and it's all about arrangement, that's why 6 factorial ways or 6p6, and all the children can interchange their position, they can be rearranged, that's why 4p4 means 4 factorial ways. So 6 factorial means actually 720, and 4 factorial means 120. 4 factorial means 24. So if you multiply 24 into 720, you will get 17,280 arrangements, total arrangements. And actually, what does factorial mean? Let me explain this. Before that, let me erase some of the parts. Actually, we use calculator, which is more convenient for us to find the solution. Yet manually, if you want to understand, 5 factorial means all the digits less than 5 will be multiplied. 5 into 4 into 3 into 2 into 1 into 1. So it will be actually 120. And 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1. That means all the digits less than the number will be multiplied sequentially, which is called actually factorial. So this is what the factorial is, the fact of the factorial is. But we are applying, we are utilizing our calculator to find the results. Let's see the next question. The next question says, four of the choir are selected to sing in a group. Then now this is a clue word, so we should not ignore which. That four have been chosen, okay, and it is about selection. Look at this here, selected have been, the word has been written as selection. So for selection we will use combination. Then they told, the first condition, there are some restrictions also. Find the number of different selections if no man is chosen. Let's see how many people are there. Total 9 people. Out of 9, here no men, the clue word is no man is chosen. How many men are there? There are only 2 men. Look at this, there are 2 men. If we subtract or avoid these 2 men, how many are remaining there? 4 plus 3, 3 women, 4 children, 7. So now all our question is, the whole of our question is based on 7 people. Men cannot be included at all. So out of 7, how many are chosen? We will have to choose 4. Out of 7 we will choose 4. Yes, it says that 4 choir should be chosen and there should be no man. Find the number of different selections if no man is chosen. So if we don't choose any man, then how many are remaining? There are 7. Except men, there are 7 people, out of which 4 people are to be chosen. So number of selection is equal to 7 c 7 choose 4, that means 4 should be chosen from 7. And we have already come to know this 7 only. First one is selection, okay. For selection we have chosen combination formula, and there are only 7. Total number of people is 7 and we are choosing 4. So it will be 7 choose 4. Then 4 people should be chosen from 7. It's not arrangement at all. So for combination we write the numerator is 7 factor total number, and then we write this 4 as well as 4, this 4, then subtraction, okay. So first the numerator, 7 is the numerator, then this, the chosen quantity should be written as factorial in the denominator, and the subtraction of both the quantities is common both in permutation and combination. So 7 factorial over 4 factorial and 3 factorial. Remember, in case of combination you will subtract both the quantities, chosen one from the total quantities, as well as the chosen quantity should be written. So 7 factorial over 4 factorial into 3 factorial is actually 35. So our answer is 35. What does the next question say? The next question says, find the different selection. This is also a combination question, because it belongs to combination, because selection is the word. Our clue word is selection. Now let's see, actually at least 2 women. That means there can be 3 women there were total three women, so there can be two women as well as three women, but not less than three. Let's see, total there were nine. Multiple times we have reiterated the question. So total nine, three women and six others. First of all, we will have to make scenario. Look at this. This is our scenario. Okay, in scenario there are three women. Out of three, we can take two. First, we are taking two. Then if we take 2, then how many should I take more? We can take 2 more because total we require 4. Okay. If we choose 3 women, then we can take 1 either children or men. So first case is, there are two cases. In first case we have chosen two women, then two from others, and then we have chosen three women, then one from others, and all of these are actually combination. So combination means we will have to apply the combination formula. So first we have chosen two women from three women, then three choose two into, then we have chosen, there were six remaining people, means children and men. Out of six, we have chosen 2. So how to write this? 3 choose 2, 3 factorial over 2 factorial and 1 factorial. Then in for the second case, 6 factorial over 2 factorial and into 4 factorial, means we will have to subtract 6 minus 2 means 4, and this 2 factorial. And if you calculate this using your calculator, you will find 3 factorial over 2 factorial means actually 3. Okay, and 6 factorial divided 6 factorial means 720 actually, as I have shown in the previous one. 6 factorial means all the numbers including 7, all the list now, I mean sequential number in descending order including 7, if they are multiplied 6 5 4 3 2 1, it will be 720. If 720 is divided by 2, 4 factorial means 24, 24 to 48, then it will be 15. Okay, or you can apply a whole of this using your calculator. You can find 3 factorial over 2 factorial into 6 factorial over 2 factorial into 4 factorial, it will be 3 into 15. Let's see the second case. Second case is we have chosen 3 women and 1 other person. So from 3 there are total actually 3 women, 3 choose 3 means it will, we have chosen 3 out of 3, and from 6 other people we have chosen 1. So 3 factorial over 3 factorial, and if we subtract 3 minus 3, it is 0. Okay, and in case of 6 choose 1, 6 factorial, and 6 minus 1 in 6 minus 1 is 5, and 1 factorial as well. So 3 factorial, 3 factorial, if they are dissolved, or let me dissolve in the next step. So 3 factorial is 0 factorial, we have already come to know 0 factorial means 1. So it is 3 factorial over 3 factorial means 1, they can be dissolved with each other. Then it is 6 factorial over 5 factorial. If you divide 6 factorial over 5 factorial, it will be 6. 6 factorial will show 720, 5 factorial will show 120. If we divide, it will be 6. So we have chosen first selection, we have got 45. 3 into 15 means 45, and second one, from second selection, we have got 6. So 45 plus 6, 51. Let me show you. We have written here number of total selection, number of total selections. In the first case there are 45, in the second case there are 6, so total 51 selections we can do. So this is the way here. Whenever you get 2 or 3 cases, then all of them should be actually shown in scenario, as I have shown over here. Look at this. First we have written that there are 3 women and 6 others. As there is no restriction or question about the others, so 6, all 6 can be written together. First, from 3 we can choose 2 because they told at least 2. So if we choose 2, then there will have to take another 2, because our choir contains 4 people. Look, in the first question you might have observed, and you may remember that we will have to choose 4 people. So out of 4, if 3 women, then there will be 1. Sorry, if 2 women is chosen, then 2 from chosen from 2 should be chosen from the remaining ones. Then if we choose 3 women, then we will have to choose 1 from the other remaining people. Then for 3, if we choose 2 from 3, we have written 3 choose 2. Then if we choose 2 from 6, we have written 6 choose 2. Then we have written, as you know how to do this. Then if we choose 3 from 3, we have written 3 choose 3. And we have chosen 1 from 6, so 6 choose 1. And the calculation has been done. I think you are now more convenient or more comfortable than in the previous case. So let's solve some more solutions. The next question belongs to 060622, paper 22, May June 24. So paper code is 060622, 0606 slash 22. That means it's an add math question. Let's see what the question says. Question number 7. 7 says, find the number of different ways the 9 letters of the word polymaths can be arranged. So arranged is the clue word, arrangements. Arrangement means permutation. When the O and A are not next to each other. That means this is the restriction. We can arrange, but there is a restriction. O and A are not next to each other. That means O and A must have someone in between them. So let's see. Total there are 9 letters. So one place. If we subtract O and A, then how many are remaining there? There will be 7 remaining. So one place, 2 place, there are 7 total, 3 4 5 6 and 7. So rest 7, they can interchange their position. But what about O and A? O can be either over here or over here, over here. That means there are total actually 8 places for O and A. How many? There are 8. 1 2 3 4 5 6 7 8. There are 8 places available for O and A. Let's see how to do this. First, we will see there are 7 remaining letters, excluding A and O. So these 7 places mean this 7, 1 2 3 4 5 6 7. So this 7 P7, there are 7 letters, and for them they have, for them there are 7 places also. So 7P7 we can write here, for which we can arrange them as 7P7, 7 places and 7 digits equivalent to each other. Then what about the next remaining 2 digits? Then there are 8 places, out of which O and A will occupy. How many places will be occupied by them? 2. They will occupy only 2 positions. Then how can it be written? There are 8 positions available. Out of 8, they will hold 2 positions. 2 places will be filled by them. How to write this? If there are 8 places, 2 are to be arranged, or 2 should be placed there, then it will be 8P2. So our ultimate arrangement is number of total arrangements. First we have arranged 7 digits, I mean 7 letters. Out of 7, 7 letters have been arranged, so it will be 7P7. Then there are 8 places for O and A. Out of 8, they will be arranged in 2 places, so 8P2. It is 8P2. So 7P7 means actually it's 7. 7 factorial, you know the numerator. If you subtract, it will be 0. Then for the next case, 8 factorial numerator, if you subtract, it is going to be 6 factorial. Then what are we going to get? If you use your calculator, then you will find 7 factorial into 8 factorial over 6 factorial, because 0 factorial means 1. So 7 factorial into 8 factorial over 6 factorial will produce 28,240 ways the numbers can be arranged. Let's solve the next question. The next question says the letter maths are together in this order. That means indirectly they are telling that we can make no change to maths. So the total there were 9 letters. Total 9 letters. Out of 9, if maths have already been arranged, we need not look at maths. Okay, this is already arranged. So how many are left? 1 2 3 4. There are 4 places are left, and whole of them is also 1 unit. We cannot ignore this, because maths can be over at the first position or second position or third or fourth or fifth. Altogether they can change their position. So all of them are 1 unit. Okay, and there are remaining 4 left, so total 5 units. First 5 units we will just arrange in 5 factorial ways. So considering maths as 1 unit, there are total there are total 5 units, which can be arranged as 5p5. Well, so 5p5 means actually 5 factorial. 5 factorial means 120. Let me show. And one more sentence has been written over here, that is, since, look at this, since maths cannot interchange their positions, I have already explained this, we don't need, we cannot arrange them, we don't need to arrange maths, only the remaining ones should be arranged. So number of total arrangement is 5p5. That means all 5 letters should be arranged or rearranged. 5 means 4 are remaining, and maths together is 1 unit, because they can also interchange their position. Altogether they can be over the second position or third position or fourth position, anywhere they can move into. So there are only 5, including the maths as 1 unit. There are 5 units, total 5 factorial ways, means 5 position and 5 letters. So 5p5. 5p5 means actually 120. If you choose, if you use your calculator, you will find 120 as the result. 5 factorial can be on top, and if you subtract 5 from 5, it is going to be 0. 0 factorial means 1. So ultimately we have got 120 as the answer. The last question we are going to solve belongs to A level mathematics, paper 53, I mean probability and statistics. So the paper code is 9709 slash 53 of the session May June 24. So this is a question of A level from paper probability and statistics 1. Let's start reading the question. This is question number 6A. 6A. The question says how many different arrangements. So our keyword is arrangements, means permutation, are there of the 9 letters in the word recorders. So one information we have already been informed that there are 9 letters. So 9 letters can be rearranged in 9 factorial ways or 9p9, but there are some hidden concepts inside this. Actually, there are some identical letters. Remember, in case of digits, there cannot be identical mostly, but in letters, if we write a letter, if we write a word, then we may find same or identical digits. In case of identical digits, that number of identical digits will divide the whole arrangements. So there are total 9 letters, out of which out of which out of which 3 hours, out of which 3 hours and 2 is are identical. Means if there are identical letters, they will be also calculated and considered properly. Let's see how to do this. Total we are arranging 9 letters. So number of arrangements, let me show the writing. The number of arrangements equal to 9p9. Okay, total we are choosing 9 letters out of 9. They can be rearranged in 9 factorial ways. So 9p9. Out of that, there are 3 R's. Look, in the word recorders, here is the word. In the word recorders, there are 3 R's. So you will have to divide by 3 factorial. And there are 2 E's. Okay. So you will have to divide by 2 factorial. So what have we learned newly? Initially, we were unaware of this, but now onwards, we will have to imbibe these concepts in our mind, that whenever there is something in identical or similar, then that will divide. Here total 9 letters, that's why it will be 9 factorial. And as there are 3 identical letters, that's why we have divided by 3, and 2 means 3 r's and 2 o's, sorry 2 is. So for 2 identical letters it will divided by 2, and for 3 identical letters it has been divided by 3. But don't write 5 factorial, because 3 factorial into 2 factorial cannot be equivalent to 5 factorial. Individually you will have to write 3 factorial for 3 hours and 2 factorials for 2 hours. So shortly, if we get identical letters or identical something, then that will divide the total arrangement. So 9p9 means 9 factorial over 0 factorial, because 9 minus 9 is 0, means 9 factorial, and 3 factorial means 6, 2 factorial means 2. So if we divide 9 factorial by 6, I mean 12, we will get 30,240 arrangements. Let's see the next question. The next question is, how many different arrangements are there of the 9 letters in the word recorders, in which there is an e at the beginning and an e at the end, and the letters r's are not all together. So there are two facts actually. First letter is e and second letter is e. So one thing is very sure, we don't need to arrange them, they are identical and they have already been fixed. So 2 places have gone away. We do have 7 more places. Out of 9 there are 7 more places. Out of these 7 places, look, 3, there are 3 r's. So from the immediate previous question we have come to know that whenever there is something identical, that number will divide. So total placing the is and with no more restriction, that means we are placing e at the beginning and at the end, then we are rearranging the rest of them. Okay, if we arrange rest of them, it will be 7 p7. It can be number of arrangement is equal to 7 p7 means 7 factorial, and 3 r's, there are 3 r's, so the 3 r will divide them. It is 840. Remember, here all the letters have been rearranged together except e. Only we didn't arrange e, because e's have already been arranged at the first and last place. Remaining there are total 7 letter total, there are 7 remaining letters which have been arranged, and we have written 7 factorial over 3 factorial. Look at this. This 3 factorial is for r's. R's are together, and they are identical and similar. That's why we have divided by 3. So whenever something or some number is identical, then we will divide by that quantity. So ultimately we have got 7 factorial over 3 factorial is equal to 840. And we should not forget that here we have supposed all of the digits have been together. There is no more restrictions. We have calculated generally, if e is at the beginning and another e is at the end, then the digits can be the letters can be rearranged in this way. Let's see the next part of this question. There are some more complicated parts inside this question. Now they have told that r's cannot be together, means negative word, not all together. R's cannot be all together. If not or negative word is used in probability, then simple way is from whole, if we subtract the positive answer, we get the required answer. Let me clarify. Look, all of the r's, they told that r's cannot be all together. Let me show you the question, that r's cannot be. Here it's written, uh, this is what the word is, r's cannot be all together. And I believe that all of you have the question paper with you, so it's not a difficult task to look at this. You can just have a look at your question, printed question. So all r's are not all together. It's not negative. First of all, we will find the probability if r's are together. So let's see, if r's are together, what will happen. Suppose all the r's are together, okay, then if all r's are together, one e it has already been fixed, last e which has already been fixed. So how many places are there remaining there? Total 1 2 3 4, and these r's are together 1 unit. So 4 plus 1, 5 factorial. Okay, so there will be placing the e's and keeping the r's all together one body. Now all of them are r's are one body. R's all together, number of arrangements. Number of arrangement is going to be total 5 places. All the r's are together. Total there were how many? 9 places. Out of 9, one place is held by R's, and E these have gone away. So ultimately there are 4 and 4 R's 1. Total 5 bodies now. Okay, there are 5 bodies, so we are just rearranging these 5 places. They can replace, these r's can be over here or there or there, and these one can go there. That means they can interchange their positions, but r's are together as one unit, they will interchange their position. So total there are 5 places. It can be rearranged as 5p5. That means for rearranging we are applying 5 p5, 5 factorial over, if you subtract 5 minus 5, it's 0 factorial, means 120. So total, if all the r's are together, then there are 120 cases. There are 120 ways in which they can be rearranged. But the question, we have not forgotten that the question is told that the r's cannot be together. What have we found? We have found that all r's are together. They told not all together. So we will just subtract. All together means they cannot be in one group. First, we have found the number of arrangements considering them in one group. Now, if we subtract this portion, if they are one group, this is the number of total arrangement. But initially, without any restriction, we have got 840. So from 840 arrangements, if we subtract when r's are together, then that will be the remaining one. The difference will be the number of arrangements if they are not all together. So we will write, what should we write? Number of total arrangements. Number of total arrangements, number of total arrangements is equal to total 840. That means considering these r's were not considered as same unit or one unit, then randomly there may be, if only e's are fixed, only e's are fixed at the beginning and at the end, then without any other restriction we have got 840 ways. 840 is the answer. Then we have supposed all the r's together, all the r's together, and at the beginning there is an e, and at the end also there is an e. Then in between them there are some places, and we have got that when all the r's are together, then there may be 120 ways. 120 ways. I can show you again. Here, look at this. We have got when all the r's are together and e's are at the end and at the beginning, then 120 ways they can be arranged. So if we subtract these 120 from all together, that means total arrangements, then that will be the answer when all the r's are not together. So what have we learned here? It's a very exceptional you know idea or concept, that whenever all together word is mentioned, then actually that first we will find not. If not is mentioned, then we will find the probability. If all of them are all together means one unit, if all of them are all together, if we find that quantity, then for not we will just do the subtraction from the total. From the total, if we subtract all together, that means arrangements of the all together, then we will get the not all together. So for not, we will subtract all together or one group from whole of the or from all of the arrangements. So this is what the solution is. I think you have understood. I tried my level best, but I am a human being. I'm not a superhuman being or something exceptional and natural. I tried my level best to make you understand. If any of my words benefits you, then it will be a great success for me, and I will keep on trying to prepare more and more videos so that they can be helpful for your study purpose. And I don't want anything. I just seek something to for you from you, please pray to the Almighty Allah so that Allah makes me more and more knowledgeable, more and more helpful, and in future I can be preparing many more videos for your better understanding. Allah Hafiz, fi amanillah.